Let us discuss two more data classes, cell and structure. They are much less used than other data classes. The most popular is matrix. Logical is very often, but they are useful when you deal with heterogeneous data, which typically form some kind of tables. Let's imagine that we want to encode the names of two cities and their population. The names of the cities are strings. The population size are numericals. How to combine all of that in one variable? You can use either cell or a structure. Cell is more uniform shape of data storage, where you put in cells whatever you want you can put. Logicals, numericals, strings, other cells, everything you want, and you can use any kind of dimensions. Now we have two dimensions, and this is how we encode it. This is a typical syntaxes with semicolon separating rows, comma separating columns, but in order to form a cell you use those figure curly brackets, curly brackets. And for structure you need fields. You name certain subsets of your structure properly, name, population, and then you indicate the number of the element of the field, which can be again n-dimensional, and then you assign values to those fields. When you collect experimental data and you have a lot of different parameters, reaction time, accuracy, condition, experiment, subject name, session, order, if there are a few sessions. All this can be encoded in structure, and it is often done this way. Cells are often used in SPM, which is not the topic of today's course, but it's better that you know in advance that you can store your information this way. And to extract something from a cell, you use, again, not simple but curly brackets. For example, if you want first element of this cell, you use a syntax like this. And if there are few elements of the outcome, you can also select them like this. It will give you first element of the first cell, which is letter K. And if you type AND here, will give you the last element of the cell 1, which is B. Also, if you use multi-index encoding like this one, it is going also to work well, but in this case it is going to be number, and there will be just one number independently of whether it is the first or the last, because there is just one element, one numerical element, while in the case of the text you have multiple elements which are distinguishable. Functions are programs that can do something useful if you know how to use them. And most of your knowledge about MATLAB is about which kind of functions are available, how to use those functions, and how to build your own functions. In fact, there is no striking difference between a function and a script. Let me remind you that both script and function files are stored in a shape of text, and they end with M extension. And you can consider this kind of file as a sort of primitive function which executes what is hard-coded there. Hard-coded means that we don't assign any input for this function. We don't give it anything when we run it. We just run it and it executes what is already written. It doesn't take anything from outside. A function can be compared to a living organism with its metabolism. Every kind of living organism has to consume something, and then there is something that it gives you back. And when you create a function, it is quite similar to the concept of creation of something new and sometimes semi-independent from your will. And it is a very exciting experience. But first of all, you need to learn how to use your functions. And this is what we are going to discuss next. There are a lot of functions, that I told you, thousands, but some of them are used very often, and therefore you need to learn them first of all. Here I listed some of very useful functions which are going to be helpful to you, but the most useful of all the functions is the function help. This function, combined with other functions, gives you a brief explanation of what this second function actually does and how to use it properly. So, if you really want to know anything about a function, or if you have doubts how to use it, type help, type this function's name, and read. This function whose gives you the list of all of your current variables, its size, the amount of information, its format, everything. You don't need to give it any argument, any input. It is going to use your environment, your current environment. It's an error because I misspelled the name of the function. There must be no E at the end. The correct spelling is this. So it works as expected, and it gives you some outcome. But you can easily read all this in the workspace. This is just an example of what kind of functions can you use. And how to figure out what do they do. This is another function, disp. Let's try to type help, disp, and learn what does it do. Just a moment, apparently the machine is busy, and now it gives you a lot of information. Display array. It does exactly the same thing as what happens when you just type the variable, but sometimes when you run a program you prefer that in your command window you get some update on the current status, timing, whatever of your script, and then you use disp function. It can display numericals, strings. It gives you also some hints about related functions, and if you click on one of those you can read what does it mean. For example, this one. This is something I use pretty often. Num to str, which means numbers to string. When you want to create a file name in order to save your data, you might need to use this kind of function. Or if you want to sign your plot, you will also need to use strings instead of numbers, even if you display numbers. Talk about the structure of a typical function. Normally, a function has its name labeled in red, its input in orange, which goes after parentheses after the name of the function, input or inputs. There can be many different inputs for the same function, which will be separated by comma. And an output. Some functions don't have any input, but most likely some kind of output is going to be there. Let's consider a few examples. This is a function called mean, which makes averaging of the input. This is the input we indicate for this function, and m is going to be the output. After we execute this expression, we get m equal to 5, which is the average of those 5 values. Other interesting function which will be used a lot is diff. This function consecutively successively subtracts each following element. It subtracts each preceding element from the following element. Like 3 minus 1 gives you 2. 5 minus 3 gives you 2. And so on and so forth. Therefore, out of 5 elements of A9, the output is just 4 values. This is a very useful function to measure the intervals, temporal intervals between effects, for example. And here there are a lot of functions which actually generate you data. You will use them a lot in order to create your design, to plan your experimental conditions, whatever is the experiment that you plan to run. But before we discuss this, let us go to MATLAB and check how functions mean and diff work. We copy this to MATLAB. We have variable A9, so there will be no problem to use this function now. It gives you 5. If you take a two-dimensional matrix, like for example A6, you can use function mean in 2 ways. Either you average up the it should be A6 here. Either you average up the columns, so this one is the average for this column, this one is the average for this column, this is the average of this column, or you can average along other dimension. Here you have 2 inputs. One is the variable itself, and the other is the dimension along which you plan to average. Now you average up
the rows. This one is the average of this. This one is the average of this row. The difference. So let's first do exactly what we have in the presentation. So let's remind what is A9, this simple array. So this is difference for A9, and it gives you always 2. But if you generate something with an irregular difference, for example, first there will be short intervals between the values, and then really long intervals. Difference will give you first short values, then long ones. So difference for those is big, for those is small. Other example of what can diff function do. It can well detect sharp spikes. For example, if you have an event here which is high amplitude and you run difference, you get the onset and the offset of this event. If the event is long enough, like 3 points block, the onset will be separated from the offset of this kind of event. This is onset and this is offset. This is what you might need when you analyze your time series data or behavioral data, which is often also time series. What I did now was an attempt to generate some data. I did it manually. While there are designated functions to generate data. Why would you be interested to generate data? Because you have to plan your experiment, or you might wish to model your experimental data, like to pretend that you have some data and test your tools, your programs, in terms of whether you can properly analyze your data or not. So those great functions are listed here.
Function zeros generates an array of zeros, and function ones generates an array or a matrix of ones. It can have any kind of dimensions. In this case, it is just one dimension, a short array of zeros of 3 elements, and a short array, horizontal, of ones, 3 elements also. After we can make easily a concatenation of those, which gives us this kind of array. And here we run another useful function, which is called repmat. It does replication again in any kind of direction, any kind of dimensions. In this particular case, we replicate 2 times the same sequence, or another way we can say we repeat it twice. After, we should consider 2 important functions for randomization. In general, in neuroscience, randomness is very important, and if you deliver tasks, stimuli, conditions, the order of such conditions is better to be random, and this is where those 2 functions can be very helpful. Function rand generates random values from 0 to 1, and this kind of argument gives us 1 row and 12 columns, an array of length 12 of random values ranging from 0 to 1. And this is random permutation. In this case, it gives values from 1 to 12 in a random order. Let's try all of those functions and generate respective variables z, o, r, p in MATLAB and in GNU Octave. Zeros. Here it is. And if we type the same thing in Octave, we get exactly the same. Ones. Totally similar results. Now concatenation. Z, comma, O. If we type here semicolon, it will do vertical concatenation, which is not what we want. So let's rerun the old version in order to assign proper values to the variable ZO. Next, repmat. So we replicate the same thing twice. Otherwise, it can be done with concatenation of ZO with itself.
We can do it 5, 6 times, any number of times, but for sure it's much more convenient to do it with a function. If you type something like this, it means that you replicate it 4 times, 2 times horizontally, 2 times vertically, or other ways it can be written like this. It gives exactly the same outcome, but a function is always preferable, because here you can replace the input argument with a variable, like for example this can be a. It doesn't know what is a, but we can assign to a any value we need, for example 10, and then this function will run well. It will replicate the same sample ZO 10 times, or if a is equal to 2, it will replicate it just 2 times. That is why functions and variables are always better than hard numbers written in your code. They give more flexibility. Let's generate our random variables. So here it is from 0 to 1 random variation. If you run it another time, it will give you new values, new numbers. Each time it will be new. Therefore you will not replicate the same number when you run it on your computer. Random is random. And this is random permutation. Here it deals with integers. There are no decimals, and if you can imagine, this is a good way to index the order of events, conditions, and again, each time you generate it, it will give you a different order. Also, functions of randomization can be used for quite efficient non-parametric statistical tests, as bootstraps, Monte Carlo models, and other great statistical tools. Very intuitive, very simple to run. However, we will not discuss those here. Just keep in mind that randomization functions can be used for many different tasks, and they're really useful to know. Let's go to the next slide, where we will do some visualization. Some plotting. When you have a row of numbers, the best way to have an idea what do you have, especially when there is a large number of numbers, is to build a plot. The function is called plot, and if it is a simple one-dimensional data array, you just put it after parentheses, and you get something like this. here for random values, if you remember, those are random, you get a plot about like this. Random numbers can be represented as a noise. Typically noise is random. Any kind of data, any kind of time series has some noise in it, and you might wish to model experimental data by combining some non-random values and random noise. And this is what we do here for the figure 2. Figure is a function which will open another separate figure, separate window, where you can plot something else. So figure just opens a figure. Here we open figure 1, and this will be the name for this figure, figure 1. And here we open figure 2. You can pick any number, but if you type the same number again, you will use the old window for the figure. By the way, this is an obvious typo. You don't use capitals for functions. It should be small line letter. In the figure 2, we first plot R. This R. R is the result of RepMat. So this line repeated 2 times. We plot this R. It will give us this kind of line. And then we type hold on. Hold on is another function which enables storing the old trace on a plot when you plot something else. Otherwise it will be erased. But before you create a variable RRA, which is a sum of R and RA. Basically this is what we model as non-random, and this is random, non-random, random. You put it together and you get a mixture of noise and data, and you plot it with some additional information, some additional arguments. After it you place a comma and letter R between 2 apostrophes. This instructs function that the line should be in red color. That is why it is R. You can use green, M for magenta, and so on. And here you get red plot, which is the sum of this and this at the same graph. Now let's try to build something totally different. We can code any continuous variable by colors. We can assume that the maximal value will be
white, and the minimal value will be black. For images, typically you use a variable with 3 dimensions. One dimension is x, other dimension is y, something that we have in all other plots, x, y, and the third dimension is the layer of the image. Typically there are 3 layers for red, green and blue, RGB. If we want to build black and white or grayscale image, we can simply replicate exactly the same in all 3. And then if we divide all this by the maximum value of the original variable, then the maximum, the peak value will be 1 and all others smaller than 1. This is exactly what is necessary for the function image. Let's try all this practically. In Octave this time. Believe me that in MATLAB it will be exactly the same. Before plotting, we need to concatenate Z and O. Then we repmat it. This variable R. Now we generate RO. I believe this is how we call it. RA. Well, yeah, we have 12 values. And now we can open a figure. This is our figure, figure 1. If we type figure 1, it doesn't give anything. We already have figure 1. Let's plot our random values. Here it is plotted. And now we open figure 2. We can move, we can reshape those figures. It's very flexible. We create RRA by summing up R plus RA.
Sometimes MATLAB asks for this forward, back, cute feedback on the content of command window. We press just forward, and now we plot this variable along with this variable. So first we plot R. This is our signal, our non-random data. Now don't forget hold on, otherwise everything will disappear. Let's do it without hold on, so that you see what happens. Yeah, everything disappears, and you get a new variable. Or if you type this RRA, you get something like this. Anyways, it will remove all the old content. If you want to keep it, type hold on, and then the old trace will stay and the new will be at the top of it, and it will be in red. Here it is. Looks nice. Now yeah, the image. First we create this three-dimensional matrix. Let's type it. We do everything in Octave. Why not continue in Octave? Copy paste. Do we have? Image. No, not yet. Finally, I get what I need. So, the first layer done. The second layer let's remove this editor out of here. Second layer done. Now we have two layers in this three-dimensional matrix, and third layer done. Good. Let's open other figure and try to build an image. Out of the variable em. It works, but it is not
very beautiful because we didn't normalize it. We missed one important step. Here there is too much of white, as you see. So everything that is higher than 1 is white. In order to avoid it, we should divide image by maximum of RRA, and this changes a lot our figure, and it looks better now. If you compare it to the previous figure where we built RRA, you will see that it corresponds well to the graphical outcome. Low values are black and high values are light gray or white. So maximum, this one, is white. As it is expected. And the next topic of today's course is the control statements. The control statements or loops are very important. If you do an operation just once, and if this operation is unconditional, you do it anyway each time you run your program, then you don't need a control statement. But if you have some uncertainty about outcome, or if you repeat the same kind of trial many times, the best way to code it is to write a loop. The most often you will do for loops, sometimes while, and another control statement which will be used often is if statement. There are other options like switch, try, and catch. They can be useful, and we use them sometimes. But those two are very important, and they are used in most of the cases. Pause is also a good function when you want to interrupt your program for a given period of time, or if you want to instruct the program to wait for a key press. This is a MATLAB function. It is very basic. In Psychtoolbox, there are other functions which do the same, but much more precise. Function pause doesn't have good temporal precision. Now we will try to write a short program which will use for loop, if statement, pause, and break. And it will use our generated by us
uh, variable RRA, which is a combination of random and non-random data.